Test 1, 2, 3. Okay, perfect. All right, so we will be starting a bit late. So if you guys want to take a water break, go get a snack. Yeah, so we're mostly going to start around 12 o'clock. So be back by then. So, welcome everyone. Welcome to the Unlocking the Past console hardware and open source gaming hardware emulators through the ages. So, let's start. But actually, before we start, I'm going to give a bit of disclaimer. These are all my opinions. These are no way the opinions of SCaLE, my employers, or any organization that I'm connected with. I am not offering any sort of legal advice. If you would like to find out the legality of certain things, I suggest that you actually contact a legal professional. But I do try my best to offer the facts, so let's get started. Okay, so before we actually jump into the Super Nintendo, let's talk about the NES, the Nintendo Entertainment System. So the Nintendo Entertainment System came out in 1985. The processor that it actually used was the Rico 2A03. And what's actually really interesting about this processor, it's the same processor that was used in the early Apple II computers, if you guys actually remember that. The reason why it was actually used for these systems is because it was cheap. So yeah, a lot of computers actually used it, like a lot of hobby type of computers. Like if people were building like their own personal computers, they were most likely using a Rico 2A03. So the Nintendo Entertainment System went on to sell, it was something like about like 100 million units. It was like one of the most popular gaming consoles of all time. It basically revived the dying gaming industry. So around the 70s, right, we had a huge explosion in the arcade industry. And many people were playing games like Pong, Pac-Man, Space Invader, you name it, typical. So after a while, a lot of companies started to invest into arcade games, and just people weren't that much interested in the arcade games. So Nintendo came out. Nintendo originally was a board game like type of company. I mean, they produced like some other stuff, but yeah, like their games weren't really like technical. It was stuff that you could play, analog for the most part. So they produced the Nintendo Entertainment System, and yeah, it started a revolution. I mean, actually, I'm going to go back on that. Atari actually started the revolution, right? And so, yeah, I can't forget about Atari. It's like, I know we're talking about Nintendo, and yeah, I should have included an Atari slide, but yeah. Anyways, so Nintendo's, what was it? Nintendo's microprocessor was about, was it 1.79 megahertz? And you think about that, and it doesn't seem like it was actually that fast, but for the time being, it actually was. So it was a good choice on Nintendo's part. Let's move on to Super Nintendo, the Super Nintendo Entertainment System. So the Super Nintendo Entertainment System was released in 1990, and it was a 16-bit gaming console known for its groundbreaking games and advanced graphics compared to its predecessor, the NES. So the processor for the Super Nintendo was the Rico 5A02, if I remember correct. Oh, it's 5A22, that's what it was. And what was it? Oh wait, what was it? Oh, yeah, the megahertz on that. The megahertz on that was 3.58. So it was basically a little bit close to double. Yeah, like double the actual speed of the NES. But its actual GPU was 16-bit. So the GPU itself made a huge difference. Model 7 graphics allowing for advanced scaling and rotation effects. Iconic controller with shoulder buttons. So we can talk a bit about the design of the Super Nintendo console. In terms of design, it was a lot more pleasant. Because if you look at the older designs of the previous consoles, they were a lot more, like square, right? So it was a lot more comfortable to hold a Super Nintendo controller than it was to hold an NES controller. Popular games, support up to 8 simultaneous sprites per scan line. Popular games include Super Mario World, which is actually voted one of the best games of all time. Yes, if you guys remember Super Mario World, you grew up during a good time. Super Mario World, The Legend of Zelda, A Link to the Past, one of the best Zelda games ever, period. Super Metroid, Donkey Kong Country. Sega Genesis, also known as the Mega Drive. Sega Genesis, released in 1988, was a 16-bit gaming console known for its aggressive marketing campaign and library of arcade ports. I'm sure you guys remember those awesome Sega Genesis commercials, right? It was like, Sega! Yeah, those are great. And if you haven't seen them, go on YouTube, check them out. It's actually pretty awesome. The Sega Genesis featured the Motorola 68000 processor. So yeah, the 68000 processor was about 7 megahertz. So interesting enough, it was like double the speed of what, the NES was. So yeah, that's pretty cool. So I'm going to throw a bit of a fact here, and I might be getting a little bit ahead of myself, but yeah, I'll talk about it right now. The Motorola 68000 processor was also used on the Neo Geo. I don't know how many of you guys actually remember the Neo Geo console. Awesome, totally awesome. The difference with the Neo Geo console is it was actually running at 12 megahertz. So I'm going to stop there, and I'll continue that once we move on to the Neo Geo. Distinctive blast processing marketing terms. Ability to add on peripherals like the Sega CD and the 32X. So this was pretty revolutionary because up until then, most games just ran on cartridges. When the Sega CD first came out, it just opened up gaming to actually using CDs. Let's see, 32X. Support for Sonic the Hedgehog franchise, which was basically Sega's, Super Mario. It's like everyone knows Sonic. Popular games include Sonic the Hedgehog series, Streets of Rage, Altered Beast, Phantasy Star 4. The PlayStation. The PlayStation, which was released in 1994, marked Sony's entry into the gaming console market, introducing CD-ROM gaming and 3D graphics to a wide audience. So, yes, Sony wasn't the first console to actually use CDs, but it was the console that dominated, actually using CDs for gaming. It used a 32-bit RISC CPU, and the RISC CPU was about 33 megahertz, if we're correct. So, yeah, we're starting to move up to megahertz compared to the previous consoles. CD-ROM drive for larger game storage. Game storage was pretty standard at around 650 megabytes to 700. So compared to what a traditional cartridge actually held, it held quite a bit. Introduction of iconic PlayStation controller with dual analog sticks. Pioneering 3D graphic capabilities. Popular games like Final Fantasy VII, also one of the best games of all time. Metal Gear Solid, actually that's a great game too, so yes. Sony took out a lot of great games during its heydays. Gran Turismo, Crash Bandicoot. And the Dreamcast. How many of you guys actually remember the Dreamcast? Fantastic console. If you were too young to actually afford a Neo Geo, again, I'm getting ahead of myself, yeah, at least you got to experience the Dreamcast. And Dreamcast was pretty much like the next best thing in terms of bringing arcade gaming to the home. Dreamcast was released in 1999 and was Sega's final home console, known for its innovative features like online gaming and visual memory units. It featured a 128-bit processor. Actually, that's wrong. So what it actually featured was, the processor was about 33 megahertz as well. It was pretty similar to the PlayStation processor. What was actually 128-bit was its GPU. Built-in modem for online multiplayer gaming. I don't know how many of you guys actually played Phantasy Star Online back in the day, but yeah, that was fantastic. Let's see. Introduction of GD-ROM disks for large game storage. Yeah, let's talk about the GD-ROM disks. In theory, they seemed like a good idea, right? And so they invested in this technology to expand the size of gaming, but they didn't really put much resources in terms of the security. Eventually, people figured out that it wasn't that difficult to actually, hack the security. And in my opinion, it's pretty much what doomed the Dreamcast. I mean, because the PlayStation 2, like, their security was actually pretty tight compared to the Dreamcast, and it took many years before you actually were to break their security. Popular games include Shenmue, Sonic Adventures, Jet Set Radio, and Soul Calibur. And now we can talk about the Neo Geo. Neo Geo was released in 1990, was a luxury gaming console known for its arcade quality hardware and high price point. So, yeah, most kids weren't able really to afford a Neo Geo back in the day. I mean, the Neo Geos were like $600, which if you take into inflation, that's like that's like over $1,000 easily. Well, what is it? I mean, like back then, the cartridges were like for the Neo Geo, there was like about $300, right? $400. So typically, your average kid was getting like a Nintendo or even a Super Nintendo or even a Sega Genesis. Most people really couldn't afford a Neo Geo, yet the Neo Geo's presence was alive and well in the arcades. And that's really how you got to experience the Neo Geo. I mean, that's how I got to experience the Neo Geo back in the day. Some of my fondest memories are actually from many Neo Geo games. It featured, man, I should have corrected this. Okay, so the CPU, I'm trying to remember what the CPU was. The CPU was a little bit more than the previous ones. Okay, oh, that's what it was. It was 12. It was 12 megahertz. So it was 12 megahertz. Its GPU was 24-bit. Expensive cartridges due to arcade quality hardware. Arcade-like joystick and button controller. Capable of displaying up to 4,096 colors on screen. Popular games include the Metal Slug series, King of Fighters, Samurai Showdown, and Fatal Fury. So during the time, right, Capcom was releasing its own fighter games, and there wasn't really many companies that could actually rival Capcom back in the day. Neo Geo was one of those companies that could actually rival Capcom, and they released their King of Fighters series games and the Fatal Fury games that came out of the King of Fighters series. Development of emulator software for Super Nintendo. Emulator software for the Super Nintendo Entertainment System has been developed over the years to allow users to play NES games on various platforms, including computers and mobile devices. So back in the day, right, like back in the 90s, this was like a huge deal, right? When, what was it, the NES 9X in its first rendition actually came out. It was actually pretty amazing that we were actually able to play these games on like a Pentium 1. It was fantastic. NES 9X, a popular open source emulator known for its accuracy and compatibility. So the NES 9X is like the de facto like emulator, at least in my opinion, right? In terms of, actually playing SNES games. Its development has come a long way and it's open source. That's not to say all these other emulators are terrible, because they're not, right? I just prefer personally the SNES 9X, and I'm sure some of you who've actually explored the SNES 9X would prefer it as well. ZSNES, one of the earliest SNES emulators, though less accurate than newer options. Heigen, a multi-system emulator that aims for psycho-accurate emulation of SNES hardware. RetroArch, a front end for emulators, including SNES offering a unified interface. BSNES, another emulator focused on accuracy, striving to replicate the SNES hardware behavior. So I've mentioned RetroArch. I will get back to RetroArch as I progress through the presentation, because it's actually really important to know about RetroArch and the achievements that it's actually made. Emulator software for the Sega Genesis, also known as the Mega Drive, has allowed users to enjoy classic Genesis games on various platforms, preserving the legacy of this iconic console. Kego Fusion, a versatile emulator that supports multiple Sega systems, including the Genesis. Gen/GS, a popular emulator with a focus on accuracy and compatibility. Genesis plus GX, a highly accurate emulator used in various retro gaming projects. Blastum, a newer emulator designed for accuracy and performance, particularly for Linux. And again, RetroArch offers Sega Genesis emulation along with other systems, providing a unified experience. So I have to say, the emulators for the Sega Genesis, well, of course, right, because you can run them on a PC, definitely run better than the Sega Genesis itself. So that shouldn't really be surprising, but it was pretty awesome to experience that, again, back in the day, to actually see that, these Sega Genesis emulators were running just fantastic compared to the old hardware. That's not to say the old hardware was terrible, but, yeah. Let's see. PlayStation. Emulators for the PlayStation have allowed gamers to revisit classic PS1 titles on modern devices, expanding accessibility and preserving gaming history. I don't know how many of you guys actually remember Bleem. Yeah, that was pretty awesome when it came out, right? Too bad that it was a very short project, and we actually know why. I'll get back to Bleem in a bit. EPSXE, a highly compatible and popular PS1 emulator known for its ease of use. The PCSX Reloaded, an open source emulator that aims for accurate emulation of the PlayStation hardware. RetroArch offers the PS1 emulation through the use of Chores, providing a flexible solution. DuckStation, a newer emulator with a focus of accuracy and performance, supporting various platforms. Medafin, a multi-system emulator that includes support for the PlayStation emulation, known for its accuracy. So Bleem came out in the mid-90s. I think it might have been like 96, 97, somewhere around there. And it actually did what it set out to do, and that was actually play PlayStation 1 games on your home PC. However, Sony did not like that very much, right? So Sony pretty much sued them, took them to court, sued them until they pretty much became bankrupt, and that was pretty much the end of Bleem. So we didn't see PlayStation emulators for quite a while as a result of that. And what you actually see throughout history is, yes, various console creators do not like that people are actually engaging in these types of projects. Even though the goal is not piracy itself, it's actually to preserve gaming history. Let's see. Development for the emulator software for Dreamcast. Emulator software for the Sega Dreamcast has allowed enthusiasts to experience this iconic console library on modern hardware, ensuring its games remain playable for years to come. Null DC, a popular Dreamcast emulator known for its compatibility and performance. Demul, another highly compatible emulator that supports Dreamcast and Naomi arcade hardware. Raycast, an open source Dreamcast emulator available on multi-platforms, including Android. Redream, a newer Dreamcast emulator focusing on accuracy and ease of use, available for various platforms. RetroArch offers Dreamcast emulation through various cores, providing a unified emulation experience. Okay, hold on. Quick. That was from Neo Geo. Should I discuss it? No, wait until the next one. Neo Geo. Emulator software for the Neo Geo has allowed gamers to enjoy the library of its high-end arcade and home console system without the need for expensive hardware, democratizing access to its games. Neo Rage X, one of the earliest Neo Geo emulators, though not actively developed anymore. Final Burn Alpha, a multi-system emulator that includes support for Neo Geo, known for its accuracy. MAME, multiple arcade machine emulator, supports Neo Geo emulation along with countless of other arcade systems, aiming for preservation. RetroArch offers Neo Geo emulation through various cores, providing a unified emulation experience. Coax, an older emulator known for its compatibility with Neo Geo games. So Neo Rage X was one of the earlier emulators for the Neo Geo, and it ran pretty well. Then we get Final Burn Alpha, and Final Burn Alpha is still being kept up, basically, right? It's a really good emulator. If you haven't checked it out, it's worth checking out. MAME. So when people think about emulation, when people think about any type of arcade emulation, it's usually MAME, because MAME supports multiple arcade boards, basically. And so a lot of this stuff ends up coming together in RetroArch, right? Like RetroArch is like the top emulator at this point because it supports so many different emulators, and it supports these emulators through Chores. And you can find all kinds of systems, right? I mean, you can find many different versions of Atari. You can find, what was that system called? Odyssey. Oh, wait, it was Odyssey? Yeah, it was Odyssey. Odyssey. You can find some of the NEC systems. So pretty much, if you experienced it back in the day, you can most likely find it on RetroArch. Challenges and advancements in emulation technology. Emulation technology has faced various challenges over the years, stemming from complexities of replicating console hardware on different platforms. However, advancements in hardware and software have led to significant improvements in emulation accuracy and performance. Hardware limitations. Emulating console hardware on a less powerful device can pose challenges, requiring optimizations to achieve playable performance. Legal concerns. Emulator developers must navigate legal issues surrounding copyright and intellectual property rights, impacting the availability and distribution of emulator software. Accuracy and performance. Balancing emulation accuracy with performance can be challenging, as higher accuracy often requires more computational resources. Compatibility. Ensuring compatibility with a wide range of games across different consoles can be difficult due to variations in game code and hardware behavior. Preservation efforts. Emulation technology plays a crucial role in preserving gaming history, but its efforts to accurately emulate older hardware and software require ongoing research and development. Although there is a lot of gaming console emulators, everything doesn't have an emulator. And part of that is there isn't enough people working on those emulators for a specific console, or the console was just too difficult to actually produce an emulator for. Advancements in emulation technology have led to several breakthroughs, improving the fidelity and accessibility of retro gaming experiences across various platforms. High-level emulation. High-level emulation techniques have enabled more efficient emulation by replicating the higher-level functionality of console hardware, rather than low-level hardware operations. Dynamic recompilation. Dynamic recompilation techniques translate console instructions into host machine code at runtime, improving emulation performance. Hardware acceleration. Utilizing hardware acceleration, such as graphics processing units, can significantly enhance the performance of emulators, especially for rendering graphics. Compatibility layers. Compatibility layers provide abstraction between emulator software and host hardware, enabling emulation across different operating systems and architectures. RetroArch and Libretto. The RetroArch frontend, powered by the Libretto API, offers a unified interface for various emulator cores, streamlining the emulation experience for users. And this is what you have to love about a lot of these emulators, right? It's like, if it's some type of PC, it most likely has an emulator. It's like you have emulators on Android, that's fairly obvious, right? But you have emulators on like BOS, which is pretty crazy. So yeah. Actually, you have emulators on that's fine. I'll leave it at that. Okay, did we go? Yeah, there we go. Despite advancements, emulation technology continues to face challenges. particularly in replicating the intricate details of older console hardware and ensuring compatibility in vast library of games. Audio emulation. Accurately emulating console audio hardware, including sound chips and effects, remains a complex task due to variations in audio processing techniques. So I actually want to talk about this, right? Audio emulation is actually fairly difficult, and that's because the sound chips have a very unique architecture. And even some of the games have like specific sound chips that even though you have the games emulated or you've had them reproduced for more modern consoles, they still don't sound the same as they originally did in the original hardware. Peripheral support. Emulating peripherals like light guns, multi-taps, and specialized controllers can be challenging, requiring additional development efforts to ensure compatibility. Online play. Implementing online multiplayer capabilities in emulators introduces technical challenges related to synchronization, latency latency and network communication. So some of these emulators actually do have net play. Kawaks, which is one of the arcade type of emulators, features net play, and it's actually really good. When it comes to gaming, for whatever reason, right? I mean, I guess it's difficult, right? Companies don't really produce the best netcode, and sometimes they have to do revisions of that netcode, and it can take quite a while before they actually get it right. Let's see. Anti-piracy measures. Some console manufacturers implemented anti-piracy measures that are difficult to replicate in emulators, leading to compatibility issues with certain games. Legal landscape. The legal landscape surrounding emulation technology is complex and constantly evolving, impacting development, distribution, and usage of emulator software. So, yeah, the legalities of things usually tend to get into the way, in the way. Over the years, we've seen many projects kind of just close up shop as a result of legal issues they've had to face. One of the more recent projects that, kind of came to an end, and it was a bit of a shame, was Yuzu. I don't know if you guys actually know the Yuzu emulator, right? So it was a Nintendo Switch emulator. And again, Nintendo in this case did not like that there was a Nintendo Switch emulator. They ended up taking the Yuzu team to court, and I think they had to pay something like $10 million in fines, and they had to basically close up shop immediately. As a result, other gaming emulator projects have closed up shop as well because they just don't want to deal with the legality of things. And so you see this just happen throughout time. Like I said, it happened with the PlayStation. It happened with, a lot of the Nintendo emulators actually. But what's really risky about this ruling is they can start coming after other projects. So the way it kind of is, emulation ROMs are kind of in a gray area, like when it comes to the law. But usually it's about if the ROM is older than 25 years, you should technically be okay. The exception is if one of the companies that actually owns the intellectual property rights to specific games decides to actually release these games, well, that's when, things start getting kind of murky. Advancements in emulation technology have also facilitated the development of preservation efforts, allowing for good archiving and accessibility of classic gaming experiences for future generations. RetroArch Libretro. The RetroArch frontend, powered by the Libretro API, facilitates the integration of emulator cores and offers features like shader support and save states. Community contributions. Emulation development benefits from the contributions of a passionate community of developers, testers, enthusiasts who collaborate to improve emulator accuracy and performance. Open source development. Many emulator projects are open source, fostering transparency, collaboration, and innovation within the emulation community. Accuracy testing. Emulator developers conduct extensive testing and debugging to ensure accurate emulation of console hardware behavior across different games and scenarios. Documentation and research. Emulator development relies on comprehensive documentation and research to understand the intricacies of console hardware and software, aiding in accurate emulation. So, open source development is very important, right? Because if we didn't have open source development, and a significant amount of these projects, these emulation projects, are actually open source. I'll bring up, for example, MAME, right? So MAME originally started off as just, being closed off, but the development team eventually realized that the way that they were actually going to improve was through open source. And even though development team members kind of just go off and, just go do something else, it's the community of open source enthusiasts that actually keep these projects going. Looking ahead, ongoing advancements in emulation technology promise to further enhance the fidelity, performance, and accessibility of retro gaming experiences, ensuring the preservation of gaming history for generations to come. Machine learning. Machine learning techniques show promise in enhancing emulation accuracy by dynamically adjusting emulation parameters based on real-time feedback and analysis. Cloud gaming. Cloud gaming platforms offer new possibilities for emulation by leveraging remote servers to offload computational tasks and provide high-fidelity gaming experiences on various devices. Virtual reality integration. Emulators incorporating VR technology can offer immersive retro gaming experiences, allowing players to interact with classic games in new and exciting ways. Legal frameworks. Continued efforts to establish clear legal frameworks and guidelines for emulation technology can promote its responsible development, distribution, and usage. Accessibility initiatives. Emulator developers are increasingly focusing on accessibility initiatives to ensure that retro gaming experiences are inclusive and accessible to diverse audience, including individuals with disabilities. So, if you're actually in these communities, right, because there's like entire communities for these projects, they're always encouraging its members to participate regardless of their actual abilities, right? It's like necessarily just because you can't code doesn't mean you can't help out these projects. And I do recommend, if you like one of these projects, if you're, find yourself willing to help out any way, contact, these development teams, or just go on these forums and just say, it's like, hey, I would like to help, continue this project and, just keep it going for many years. Comparative analysis. One moment. Oh, we're good. Comparative analysis. Game console hardware versus software game console emulators. Comparing game console hardware with software emulators provides insights into the advantages and limitations of each platform for retro gaming enthusiasts. Hardware authenticity. Consoles offer an authentic gaming experience, replicating the original hardware's look and feel. Physical media support. Consoles allow for the use of game cartridges or discs, preserving the tactile aspect of retro gaming. Controller compatibility. Console hardware ensures seamless compatibility with original controllers, enhancing gameplay nostalgia. Limited availability. Retro consoles may suffer from limited ability, driving up prices in secondary market. Hardware maintenance. Physical consoles require maintenance and repair over time, posing challenges for long-term preservation. So, if you have some of these older consoles, you know what type of problems they can have. And, you could always buy a new console, right? I mean, unless you want to be, hardcore about it and actually replace parts yourself. It's a lot easier to just deal with emulators. I'm a game enthusiast, right? So I own many games. And I still have my consoles, but I enjoy playing retro games on, on a PC basically, because it offers just so much more freedom. Software emulators offer flexibility and accessibility, enabling users to emulate retro gaming consoles on a variety of modern devices. Platform versatility. Emulators are available on multiple platforms, including PCs, smartphones, and gaming consoles, expanding accessibility. Save states and cheats. Emulators offer feature save state functionality and cheat support, enhancing gameplay convenience. Graphic enhancements. Emulators can apply graphic enhancements such as high-resolution rendering and texture filtering, improving visual fidelity. Legal considerations. Emulator legality varies by jurisdiction, and usage requires users to navigate potential copyright issues. Controller customization. Emulators allow users to customize controller inputs, supporting a wide range of input devices for gaming. So, yeah, in many of the older systems, you couldn't exactly cheat on some of these games, right? Like if you're playing some of these old hardcore, like, old school games, like let's talk about like Ninja Gaiden, right? Which is just like super difficult. Yeah, with some of these emulators, you can actually just save wherever you want. I mean, what was it? There was like Game Genie. Game Genie was a thing too, right? But Game Genie, in terms of its abilities, was actually kind of limited as well. So it's just nice not having to keep on dying, right? And playing the same game over for a very long time up until you actually become really good at it. It's like you come across a difficult area in the game, you can just save it there. Cost comparison. Emulators are often most cost-effective than purchasing physical consoles and games, especially for rare or out-of-production hardware. Preservation efforts. Emulators play a crucial role in preserving gaming history by enabling access to rare and discontinued hardware and software. Online play. Emulators can support online multiplayer functionality, enabling players to connect and compete in retro gaming communities. Performance optimization. Emulators can leverage modern hardware capabilities for enhanced performance, such as high frame rates and smoother gameplay. Legal uncertainty. Emulator legality is a complex issue with potential legal risks associated with ROM distribution and copyright infringement. So, in the distribution of these emulators, you don't get any games, right? You have to find the games yourself or produce your own ROMs, basically. It's also the same with the Chores, basically, right? It's the other one too. It's like you have to find like the system bio files and all these different types of things, depending on what type of emulator you're actually using. A lot of this stuff isn't directly supported through the development team for very obvious reasons. The online play, right? It's like I love that that certain emulators actually have net play, because I just love playing with people from all over the world, people that I normally wouldn't play with as a result of that. Let's see. Community support. Okay, we're still there. Emulator communities provide resources such as ROMs, documentation, and troubleshooting assistance, fostering collaboration and knowledge sharing. Customization options. Emulators offer customization options such as shader support, filter screens, and aspect ratio adjustments, allowing gamers to tailor their gaming experience. Retro gaming preservation. Emulators contribute to the preservation of retro gaming culture by making classic titles accessible to a wider audience and preventing hardware degradation. Performance consistency. Emulators may struggle to achieve consistent performance across different hardware configurations, leading to potential compatibility issues. User interface. Emulator user interface may vary in design and functionality, with some offering intuitive navigation and others requiring more technical expertise to configure. Yes, there are emulators you can just start immediately playing with, and there's other emulators that will take you a bit of time until you get the learning curve to actually be able to manage these emulators. So it can be a bit intimidating depending on what type of emulators you're actually using, but there's emulators that are just easily accessible. Ultimately, the choice between game console hardware and software emulators depends on individual preferences, priorities, and legal considerations. Emulation accuracy. While emulators strive for accuracy, they may not perfectly replicate the behavior of original hardware, leading to occasional discrepancies in gameplay. Accessibility. Emulators provide a convenient and accessible means of experiencing retro gaming titles without the need for physical hardware. Retro gaming community. Both console hardware enthusiasts and emulator users contribute to a vibrant retro gaming community, sharing their passion for classic titles and preserving gaming history. Legal compliance. Users should ensure compliance with copyright laws and licensing agreements when using emulators and ROMs, respecting the intellectual property rights of game developers and publishers. Hybrid solutions. Some enthusiasts combine physical console hardware with emulators, leveraging the benefits of both platforms to create their ideal retro gaming setup. So, the retro gaming communities are pretty awesome, right? I like to consider them in some way a bit of historians because they preserve a set of knowledge that, as a result of time, would be lost if it wasn't for all these enthusiasts sharing what they know, talking about the games that they actually enjoy, and willing to just give people the ability to be able to have these experiences that they have experienced over time themselves. Let's see. One moment. Interconnected evolution of consoles and emulators. The evolution of retro gaming consoles and emulators is deeply interconnected, with each influencing the development and advancement of the other. As console hardware evolves, emulator developers work to accurately replicate its functionality on modern platforms. While emulator innovation often drives improvements in retro gaming experiences and preservation efforts. Hardware documentation. Emulator development relies on comprehensive documentation and research into console hardware architecture, leading to a better understanding of retro gaming systems. Accuracy testing. Emulator developers conduct extensive testing to ensure accurate emulation of console hardware behavior, contributing to preservation efforts and enhancing the authenticity of retro gaming experiences. Community collaboration. Console enthusiasts and emulator developers often collaborate to share knowledge, resources, and preservation efforts, fostering a vibrant retro gaming community. Legal frameworks. The legality of emulator software and ROM distribution is influenced by involving legal frameworks and copyright regulations, impacting the accessibility and availability of retro gaming experiences. Technological advancements. Technological advancements in hardware and software drive innovation in both console design and emulator development, leading to enhanced retro gaming experiences and preservation efforts. The development of emulator software has played a significant role in the preservation and accessibility of retro gaming experiences, allowing enthusiasts to enjoy classic titles on modern devices and platforms. Preservation efforts contribute to the preservation of gaming history by providing access to rare and discontinued hardware and software, ensuring that classic titles remain playable for future generations. Community engagement. Emulator communities provide resources such as ROMs, documentation, troubleshooting and assistance, fostering collaboration and knowledge sharing among retro gaming enthusiasts. Technological innovations. Emulator development drives a technological innovation as retro gaming experiences with advancements in emulation accuracy, performance, and features, enhancing the authenticity of gameplay. Again, I emphasize legal compliance for very obvious reasons. Okay, and actually what's really awesome about the communities as well too, they've been able to preserve specific groups, and even in some cases, specific individuals have decided to take it upon themselves to preserve manuals, the original manuals that came with a lot of these games. Because a lot of these manuals have kind of just been lost over time as a result of you know, I guess people that aren't stuff or whatever reasons. And there's entire groups that are dedicated to preserving, gaming history, which includes these gaming manuals. And the gaming manuals themselves, especially for some of these older games, tend to give you insight into the actual storyline of these games that you just wouldn't know if you didn't read the actual manual. Conversely, the evolution of retro gaming consoles has also influenced the development and advancement of. Wait, okay, that's one, yeah. Influences the development of advancement emulator software, providing emulation developers with new challenges and opportunities to improve retro gaming experiences. Okay, I'm going to skip that. Let's go. Performance optimization. Emulators leverage advancements in hardware and software technologies to improve performance, such as dynamic recompilation and hardware emulation, ensuring smooth gameplay experiences. Peripheral support. Emulator development includes support for emulating peripherals like light guns, multi-taps, and specialized controllers, enhancing gameplay authenticity and compatibility. I'll take a break for a minute. So it would be pretty awesome if you can use the original hardware on your PC, right? Like it's like about like the original light gun, right? I know there's been modifications when it comes to certain equipment. Like you can use variations of the light gun with, what is it like Bluetooth basically. But using like the light gun itself won't work in is it on a modern PC screen. Let's see. The interconnected evolution of retro gaming consoles and emulators underscores the symbiotic relationship between hardware innovation, software development, and gaming culture, shaping the landscape of retro gaming experiences. Innovation feedback. Innovation feedback loop. The feedback loop between console innovation and emulator development drives continuous improvement in retro gaming innovation, and console design and vice versa. So I don't know if you guys actually been looking at the market, right? I mean, classic gaming, retro gaming is really huge. So new developers have started to replicate some of these older systems that have been out of the market for quite some time, and the aesthetics of these newer systems has like a more retro type of feel. Or if it's not just like a different thing, they'll actually get the license to like reproduce these systems like in their mini versions. Yeah, it's pretty cool. It's pretty cool how people and even companies have been making these efforts to just preserve classic gaming. Nostalgia and revival. Retro gaming experiences fueled by emulators invoke nostalgia and revive interest in classic titles, contributing to a preservation and celebration of gaming history and culture. Community engagement. The retro gaming community plays a vital role in the interconnected evolution of consoles and emulators, driving innovation, sharing knowledge, and preserving gaming heritage for future generations. Technological convergence. The convergence of hardware and software technologies and retro gaming experiences blurs the line between physical consoles and emulated platforms, offering diverse options for enthusiasts to enjoy classic titles. Future prospects. As technology continues to evolve, the interconnected evolution of retro gaming consoles and emulators will likely lead to further advancements in emulation accuracy, performance, and accessibility, ensuring the continued relevance and enjoyment of retro gaming experiences. Ultimately, the interconnected evolution of retro gaming consoles and emulators reflects the enduring appeal and cultural significance of classic gaming experiences, inspiring creativity, innovation, and community engagement among enthusiasts worldwide. Cultural impact. Retro gaming experiences resonate with gamers of all ages, transcending generational boundaries and fostering a sense of shared nostalgia and appreciation for gaming heritage. Educational value. Emulator development and retro gaming preservation offers educational opportunities to learn about computer science, hardware engineering, and gaming history, inspiring future generations of developers and enthusiasts. Technological legacy. The interconnected evolution of consoles and emulators leaves a lasting technological legacy, shaping the trajectory of gaming innovation and cultural expression in the digital age. Community collaboration. The retro gaming community thrives on collaboration, creativity, and mutual support, celebrating the shared passion for classic titles, fostering a welcoming environment for enthusiasts to connect and collaborate. Continued exploration. As the retro gaming landscape continues to evolve, the interconnected evolution of consoles and emulators will continue to inspire exploration, discovery, and appreciation of gaming's rich and diverse history. So, gaming in general is just awesome, right? I mean, it has many benefits for many people, especially children, right? I mean, people like to criticize gaming and say that, it just leads to children becoming dumb. That's not true at all. It inspires creativity in not just children, and people in general, right? Inspires creativity, problem solving, pattern recognition abilities. There's been studies done on senior citizens where senior citizens were basically playing games. Oh, well, they tested senior citizens to see what their cognitive abilities were before they had them on a gaming program. And so senior citizens basically played games for 6 months as part of this experiment, and they found that overall their cognitive abilities improved as a result of gaming for at least 1 hour a day. So, yeah, it's pretty awesome. And I think that's it. Yes, we are done. You guys have any questions? If not, we're good to go. Yes. So the reason I decided to not go with the demo is because sometimes things don't work out well when you're doing stuff live, but you can see plenty of demos. I mean, there's a lot of stuff on YouTube, right? It's just, yeah. I decided not to go with the demos because I just didn't want to get into the issue where, there might be legal issues or, things might just not work out. The demo gods wouldn't have liked it, so yeah. So they go after the development team, right? And sometimes they go after entire communities. So usually what they do is they find out who's actually running these communities, and then they decide that they're actually responsible. No, tell me more. Mm, okay. Yeah, definitely will. So Dolphin, uh, Dolphin's cool. Like I like Dolphin, right? And Dolphin's pretty much getting ready to face the same issues that Yusu and Citra are pretty much facing, or I should say they already faced. The the development team for Dolphin is actually worried about it. I mean, the stuff's open source, right? So the code's actually out there, so anyone can just continue the project, even though they get taken down. But the team themselves have kind of expressed worry about what's been going on since the legal precedent has been set as a result of the court's rulings from Nintendo and the Yuzu team. Anyone else have more questions? No? Okay, we're good. Thank you, everyone, and enjoy the rest of the convention.
Can you all hear me okay? Good? Sweet. Lovely. I'll give it 4 more minutes and then we'll get started. I know it's the end of the conference and everyone probably wants to go home because it's Sunday. Just going to give it 1 more minute and then I'll get started. All right, I'm going to get started. So, good afternoon, everybody. My name's Jamie Coleman. I'm going to be talking today a little bit about AI because, you know, we have to talk about AI these days. So, yeah, thanks for attending. I know this is one of the last sessions. You could have gone to any of the other sessions. A bit of an introduction about myself. So, yesterday I did a talk and I was severely jet-lagged. Today I'm not too bad. It's not too late in the UK. But my name is Jamie Coleman. I am a developer advocate for Sonatype. I used to be a developer on mainframes for Kix, if you've ever heard of that. Worked on WebSphere for a while, OpenJ9, and then realized I could do this as a career, so I started doing this for IBM for a little bit. Got bored of talking about microservices over and over again, so decided to get into a new industry to say, so I started talking about security, which is all good fun. Who's heard of Sonatype? Hands up, anybody? One person, okay. So not that many, which means it's worth me being here, which is good. So you've probably heard, who's heard of Maven Central? Maven Central, hands up? No? Okay, obviously not Java developers here. Maven Central is the main Java repository for open source dependencies. So if you haven't heard of that, and if you're a Java developer, that's where you generally go to get your dependencies. This is something we have run and maintained at Sonatype for, I think, the past 12 years. And it's something we do for free for the community. It runs on AWS, so you can imagine our AWS build is huge. I think we've recently just served over 2 trillion artifacts from Maven Central, so yes, a lot of people use it all the time. Some of the other products you might know Sonatype for are stuff like Nexus Repository. It was the first artifact repository in the world. I'm not going to be talking specifically about any products today. I might talk briefly about Firewall because it uses some AI, but that's about it. So the agenda, what are we talking about today? We're going to talk about the artificial intelligence revolution, where it started, where it is today, the current state of artificial intelligence. I have got ChatGPT to generate me some slides on the advantages and disadvantages. Not my slides, not my words, and I want to see if you can see any bias. I asked it the same question. I just changed the word advantages to disadvantages, and there is bias, so I want to see if you could spot that. I'll talk about a little bit, should we be worried as engineers, software developers, etc. Some uses for AI that we can use as developers and engineers. How Sonatype have used AI, because we've been using it for the past 5 years. And just generally my conclusion and what I think about it. So AI, the AI revolution. AI is not new. AI has been around for a very long time. In fact, if you know Alan Turing, considered one of the godfathers of computing. He didn't invent the first computer, but he did take the designs for the first computer in World War II and build it, because the British government was desperate to crack the Enigma code that the Germans were using to send communications. But in 1950, he already saw that AI was going to be a thing. He created the Turing test, which essentially is a test to test how well AI is, and if you can conceive it as more like a human. Then we move on to the logic theorists, which were one of the first AI programs in history. So again, AI is not new. This is 1995. It's been around a long time. The first chatbot in history, 1966. We all probably think chatbots are new. They are not. They've been around a very, very long time. And then, yes, IBM Deep Blue. You may have heard of that. The Roomba was the first ever bit of hardware with AI inside of it in our homes. IBM Watson, you've probably seen IBM Watson competing on Jeopardy. Again, that's AI. Eugene Goodsman, again, more AI. I'll go into more details about this stuff. And finally, we've kind of ended on ChatGPT, where we are today. So if you don't know what the Turing test is, the Turing test essentially is a test to test a machine's ability to exhibit intellectual behavior equivalent to or indistinguishable from a human. So if a human essentially can't distinguish if it's AI or not, then it kind of passes the Turing test. We move on a bit later to IBM Deep Blue. This was first developed in 1985, so quite a while ago. Essentially, it was developed to take on the world champion in chess. Its first attempts, it tried to beat him. It lost. It won 2 times, and the champion won 4 times. But IBM being IBM, they were not going to let that stop them. So it got upgraded in 1997 and once again challenged the world chess champion. It then beat him. 6 matches over several days, 2 to IBM, 1 to the champion, and 3 draws. So already in 1997, we can see AI doing things that humans can do and even better. IBM Watson, don't know if you've ever used this before. This was kind of IBM's answer to AI recently. I don't work for IBM anymore, so I can say what I want. It's one of these things where IBM tends to be a bit of ahead of the curve. They like to invent things that are ahead of their time. I've held the first tablet, which came out in the late 90s. Nobody else had a tablet, but it was that thick, it was very heavy, it was just ahead of its time. IBM also invented the first smartphone, I think early 2000s. Huge device, again, too heavy, too ahead of its time. IBM created Watson. They actually sold off part of Watson, the health part, and then of course ChatGPT came along and made AI sexy again. IBM, they're probably sitting there thinking, shit, why did we sell it off again? Seems to be a repeating thing with IBM. But yes, this was developed to basically answer questions on the Jeopardy show. If you haven't seen it, take a look. It actually won the prize against some of the best quiz masters in the world. The machine to power the thing probably cost $1 million in electricity, but that wasn't the point, right? They were trying to show that AI could do amazing things. Now, in my opinion, IBM Watson was perfect for healthcare because new things come out all the time in healthcare. Doctors can't know every new thing that comes out. New things come out every day, but AI can. So doctors could use AI to find remedies, solutions, the latest healthcare for patients. But like I said, IBM sold it. Eugene Goodsman, possibly the most advanced AI chatbot of its time. It's developed in Russia. Funny enough, it was actually developed to portray a 13-year-old Ukrainian boy. Bit of irony there. It was done that so you could forgive it if it made mistakes. So it was trying to be a bit more like a human. In 2005 and 2008, it finished second in Turing test competitions. And then in 2014, it had another attempt on the 60th anniversary of Turing's death, and it convinced 33% of the judges it was a complete human. So some declare this as actually passing the Turing test. So the current state of AI, where are we now? Well, we all can see all these image generation things, the video generations, which are all good fun. If you haven't had a go with Adobe Autofill, very, very cool. You can pretty much give it any image and ask it to add whatever you want on top. But what's made AI popular all of a sudden? Because there wasn't AI tracks generally in conferences a few years ago, and now there is. Well, ChatGPT came about, right? My mom, who is computer illiterate, takes her about 10 years to type her name. She can actually use ChatGPT, right? They basically made this really, really convenient by putting it in a web browser that anybody can use. Where you compare that to things like Watson, you'd have to connect to APIs in the back end. So unless you were an engineer, it was pretty much impossible to use. But ChatGPT opened AI pretty much to everyone. So this was released in 2022. I think it was one of the fastest growing pieces of software in the world in terms of usage. Yeah, there we go. That's the second point there. So many of the chatbot systems are based on this technology, such as Google's Bard. I know a lot of them are creating their own technologies. It has a tendency to confidently provide inaccurate information. So it will very confidently say something, making you, the user, think it's true, but a lot of the time it's not. So do be careful when you use these technologies to fact check whatever you're doing. They're very good at getting you started with projects, but I wouldn't rely on them too much for anything too comprehensive. But these things come with problems, right? So in order to train ChatGPT on stuff like, because humans, they put horrible stuff into these things, right? They ask it horrible questions, they see what they can get away with. So of course, people have to train this. So what did OpenAPI do? They essentially outsourced this to some Kenyan workers, right? Paid them less than $2 an hour, and they were exposed to some of the most horrific, imagine what the most vile humans are putting into ChatGPT, right? And they had to sift through this, rate this, look at it, and they basically expressed this as such as torture because it was so bad. Now they don't do this anymore. This was very early on. But, you know, these technologies, they come with problems. They come with issues. You know, we have to train this stuff, create the models. So as developers, as engineers, there's lots of uses for AI. So we produce a supply chain report. We do it once every year. It basically talks about the state of open source generally, talks about different ecosystems. Because we own Maven Central, we have a lot of data on the Java ecosystem specifically. But yeah, so do check that out. But there's lots of different things we can do, right? So just some examples of AI things that can help us be more productive. Code snippets you might be aware of allows you to generate error-prone and performance-optimized codes. GitHub Copilot, everyone's definitely heard of that. Auto regex is one of my favorite because I hate writing regex. It's just one of those really annoying things that every time I come across it, I'm like, oh, not again. But this can generate it from you with just natural language. It is really good at it. So if you hate writing regex like me, definitely use some of these technologies. And Minify, this is quite good. It can generate documentation because we just want to get on, create business value. We want to play with the technology. We don't really want to write documentation. So there's lots of different AI tools that can help you do that. So these are just some examples of the way AI can help us as engineers. So should we be worried? Right, onto these generated slides. I'm going to go through them quite quickly. They all make sense, they're all valid points. So we'll start with the advantages. So basically what I asked ChatGPT is I said, can you give me 10 slides on the advantages of AI? And then I changed the word advantages to disadvantages. That's all I did. So see if you can see any bias between the advantages and disadvantages. So increased efficiency, this is what it came back with. AI technologies can automate repetitive and mundane tasks, freeing up us as human resources to work on more complex and creative work, things like that. Enhanced decision making, AI can analyze vast amounts of data, as we know, and it can quickly and accurately enable more informed decision making. AI-powered chatbots and virtual assistants can provide instant and personalized customer support. So, you know, they can use your data, they can see what you're going to talk about, what you've generally asked in the past, and it can tailor the experience for you as a customer. Cost saving, so AI can help businesses reduce costs by automating processes, eliminating the need for manual labor. So all boring tasks, I mean, that is my opinion with everything. If it's a task that you're repeating over and over again, just automate it. Whether it's with AI or something else, yeah, just always automate everything. Innovation and creativity. I actually quite like, so I'm on the board of a few conferences and I have to look through conference submissions. If you're submitting to conferences, please don't use ChatGPT. I can tell very, very quickly if you've used that to generate an abstract. ChatGPT and a lot of AI like to use very similar wording that most humans would never normally use in a normal conversation. And as someone who's going through lots of abstracts, I can see straight away if you use ChatGPT. I mean, you're welcome to use it. I've used it before, but make sure you change it enough because people will pick up. People think, you know, it's this amazing technology, but it is quite predictable, and I can see that going through these things over and over again. Improve safety, so AI can be employed in various industries to enhance safety and reduce risk, such as autonomous vehicles, etc. Again, going back to the personalized experience thing, such as the chatbot. So the conclusion, again, all this was written by ChatGPT. The conclusion here is artificial intelligence offers numerous advantages across various industries, from increased efficiency, enhanced decision-making, to improved customer experiences and cost saving. AI is transforming the way we work and live. Embracing AI technologies can unlock new opportunities and drive innovation. Right, so now, disadvantages. Again, asked it the same question, just changed the one word. First of all, job displacement, the thing most people are probably worried about with AI. AI and automation technologies have the potential to replace human workers in various industries. Yep, I'd agree with that. Lack of human judgment and intuition. AI systems lack the ability to exhibit human-level judgment, intuition, and creativity. For example, if you had an AI car, if you had a self-driving car that's using AI, that AI has to make decisions. For example, a child jumps out in front of that car when it's going down the road. What does it do? A normal human, yes, we would just react, but AI has to make horrible decisions. Does it go onto the opposite side of the road and smash into another vehicle? Does it mount the pavement and kill someone on the pavement? You know, all these AI systems have to do this, but they lack the human judgment that we have as humans. Privacy concerns, we've seen that lots in the news where these AI technologies are consuming private data where they shouldn't be, so that's also a privacy concern. Over-reliance on AI technology can make societies vulnerable to system failures and cyber attacks. Personally, I don't think that's an AI problem. I think that's just a technology problem in general. You know, if our phones all of a sudden stop working for a couple of weeks, you know, a lot of society would go crazy. So I don't think that's particularly an AI issue. Ethical considerations, again, they amplify biases based on the data they're trained on, so they can lead to unfair discriminating outcomes, like we see in the news as well. Lack of emotional intelligence. They have no emotion, really, which is very good for making very specific decisions where you don't want that to factor in, but a lot of the time we do want human emotions to factor into decisions. Unemployment and income equality. As AI automates certain jobs, it can exacerbate income equality and create a divide between those who benefit from AI and those who do not. Lack of accountability. Who's accountable for the decisions AI makes, right? If AI is involved in military and, you know, for example, it makes a decision to hit a target and that causes lots of civilian casualties, who's to blame for that if the AI is the one that's made that decision? So in conclusion, again, all this ChatGPT generated, while AI offers numerous benefits, it is important to be aware of the potential disadvantages. Addressing these challenges requires careful consideration, regulation, and ethical frameworks. Can anyone tell me the differences between advantages and disadvantages in these slides? Anybody? It's really simple difference. I'll go back. Really simple difference. Anyone? Okay. Advantages. Every slide has 3 points, right? Why have they only given me 2 points for disadvantages? I can definitely add another point to every one of these slides. All I did is ask it, one word difference, but of course AI is not going to sit there and, you know, say it's terrible. It's going to reduce that, but that's bias, right? That is just bias, and all I've done is change one word. So maybe I should be a little bit worried. It did do a good job at generating those slides, to be fair. I was quite impressed. I don't think there's going to be a robot standing up here anytime soon, but, you know, it did a good job. But should we be worried as engineers? Should we be worried about AI taking our jobs, this, that, and the other? So yes and no, for different reasons. Now, I think we're a long, long way until we've got robots like this with AI in them. So a lot of jobs just simply cannot be automated. I love this. This is a brilliant little meme. To replace programmers with AI, project managers need to accurately describe what they want. So I think we're safe for the time being. I think we're good there. So with me, my opinion on AI is kind of, I don't think it's going to replace all our jobs anytime soon, but I feel that someone who knows how to use it very well might. So if AI is a thing, it's here to stay, it's really easy to use. I use it all the time for lots of different things. For example, I created a personal website. I'm a back-end developer. I don't do front-end. I kind of started staring at HTML and CSS thinking, oh, God, I haven't done this since university. I don't even know where to start. And then I went, bing, ChatGPT can generate it for me. And it did actually do a half-decent job at generating most of the code I needed. And because of that, I went through the code, reminded myself how HTML, CSS, and JavaScript all work, and then managed to create a basic website. So I think my opinion, again, my opinion, is I don't think it's going to replace our jobs anytime soon, but I think if you're not using it, someone who is probably going to be more efficient and might take your job. So kind of the reason why I'm here today and talking to you, talking about open source, why we love open source, but the things that can go wrong by using it and how AI is basically involved there. So cyber attacks are rising in sophistication. Nowadays, it's not just them trying to steal money off us, but these are state-sponsored attacks, right? These hackers are sponsored by different countries, and they're trying to take down our infrastructure. They're trying to take down our power plants, our drug delivery systems, our drug productions, and even, you know, logistics in terms of getting fruit and vegetables and everything into our supermarkets. And they're not doing this straight away. They're finding vulnerabilities in our systems and waiting for the opportune moments to take advantage of these things. So you might be living right now, today, with a hacker who's got access to your system who hasn't done anything. And what they might be doing is waiting for a specific time, like around Christmas time or something like that, when your systems are going to be hammered and you've got a lot of customers. That is when they come in and they activate their hack and try and do as much damage as possible. Now, Maven Central, it was one of the first repository systems in the world for open source, and especially a large one. And there were certain steps that were made very early on with Maven Central that weren't made with some of the other repositories, like the Node one and the Python one, etc. And for example, the main thing there is proof you have to own the domain, right? So for example, if I'm uploading something to Maven Central that's from Apache, I have to own the org.apache domain, right? Otherwise, I cannot put anything up there that's org.apache. So yes, people didn't like that at the beginning, and that's caused Sonatype a massive headache because proving you own the domain, and this is very manually intensive for us. But it stopped lots of bad stuff getting into Maven Central. So for example, different ways people do it. They'll use dependency confusion, so they'll add a version number of 999999 or something like that. So everyone who goes out and gets the latest is going to pick up that, which could have a vulnerability in. They could make a slight typo squatting, so instead of log4j, it's log4j, and you as an engineer, you'll type in you want that dependency, you make a typo mistake, and all of a sudden you get the wrong dependency with malware in. And again, also typo squatting, as you can see, Apache spelled different. Now, with Maven Central, you can't do the top two because you have to own the first domain, right? But unfortunately, you can go and create your own domain with a different named Apache, and that would be allowed. But a lot of different, like I mentioned, repository systems do not have these things. I don't think, so Maven Central, there was only been malware in there once in its history, and we put it there for a test, right? Whereas you look at Python and you look at Node, their repositories are absolutely full of malware. They're trying lots of different things to fix that situation. We scan everything that goes into Maven Central. Now, we will never remove anything with a vulnerability because that is a mistake of someone coding. And if we did that, for example, pull down the vulnerable version of log4j, one of the worst Java vulnerabilities in history, it would break lots of people's builds. But we do remove malware because malware is built specifically for malicious intent, whereas vulnerabilities are generally a mistake of an engineer which introduces a vulnerability. So all this stuff's hard, right? It's a new thing we're having to deal with. Before, we didn't have to deal with having to monitor the security of our open source, but the bad people are taking advantage of this. They know nowadays everyone's consuming open source, and networks, our firewalls are pretty good, so they're trying to find other ways into our systems. So yeah, like I mentioned, everything's rejected from Maven Central. Now, we're trying to update Maven Central to give you kind of project scoring, so you can see whatever open source project you're using, it has a score. And that's built in different ways. Here, we're just basically giving you vulnerability data, but project scoring can be things like the health of a project. So when a vulnerability comes out, how long does it take for that project to fix that vulnerability? How often do they do releases? How many people are using that project? So all these things kind of come together to give us a good idea of the health of certain open source projects. But unfortunately, engineers, developers, we're pretty slow to change. So like I mentioned, log4j, worst vulnerability in Java history, right? So this was in May 2022, I think about 6 months after log4j came out. We were talking 51 million downloads and 33% of downloads, I think, in the last 24 hours with a vulnerable version, right? We fast forward to today. I took this today. We are now at 354 million downloads of the most vulnerable Java vulnerability in history. And over the last, I think it's now been updated to 7 days. Over the last 7 days, 33% of all log4j downloads is still that vulnerable version. So we're kind of responsible for some of this stuff. We can actually see what countries are downloading it and how quickly they're fixing. And I always like to think as humans, we're a very reactive race rather than proactive. So, for example, we fix stuff when it becomes a problem rather than fixing it before it's a problem. So speaking to developers, it's quite hard when you're talking about security because they don't really care until it is a problem, right? And for example, we could see when this happened, Taiwan, for example, was downloading lots and lots of the vulnerable version. Now, at the same time, state-sponsored hackers from China started attacking Taiwan, attacking all the vulnerable versions of log4j. Then, Taiwan reacted to that problem, and now they, as per country, they have probably the lowest amount of downloads of this vulnerable log4j version, right? So again, humans, we don't tend to fix these things or react until it becomes a big problem to us. But that doesn't mean we shouldn't use open source. Open source is amazing, right? I mean, 90% or around 90% from the research we've done of new applications is open source code. We didn't write that 90%. Imagine if we did. You know, how much slower would it take us to get things into production when we had to write the code for all the dependencies we've consumed? Dependency management, so this is an average Java project. We'll have about 150 dependencies. Each one of those will have about 10 releases per year. So we're talking 1,500 open source releases per year that we have to manage. And before open source and before the hackers were taking advantage of this, we didn't have to care so much about the security. And we have no idea. I mean, you've probably all seen this. This does the rounds. But it could be, you could have some random person in Nebraska fixing something that hasn't worked on it since 2003. And all it takes is a bad actor to take over that project and essentially do bad things that we are going to start consuming. And it gets even worse because, for example, this is importing the Spring framework. You import one dependency, that dependency relies on these dependencies, that pulls in these dependencies. So knowing the health of everything that goes into our applications is not easy. Okay, so how's cybercrime changed? Well, everyone has this perception of cybercrime that, you know, it's people in a dark basement, they're doing really difficult tasks, it's really detailed plots, etc., you know, really high tech. Reality, it's not. Some of these hackers are not they're not actually that well trained in software engineering. They kind of go for simplicity. They try and find the most simple way to essentially attack people. So we have this perception that it's this really hard thing. Now, now you can go and get malware as a service. Yes, there are services out there which will generate malware for you. And people are taking advantage of AI to generate malware. Some of these services use AI. I mean, I've actually typed it, I don't know if you can still do this, but I've typed into ChatGPT, generate me malware, and it's done it. It's wrote the code for malware for me, right? So we've got to be quite careful that as great as this technology is, it can be used for bad things as well as good things. I had some of these slides in my previous presentation, which I did yesterday. I'm going to put a caveat on the actual amounts here. I got a bit of feedback. I mean, I've shown these slides probably about 15 times. No one's ever actually said anything. But a caveat on the actual numbers, because some of this came from a source which I was told might not be so reliable. I actually stole these slides from a colleague of mine, so I'm going to have a word with him when I get back just to let him know. But forget about that so much. I mean, have a think about how much this is costing us, right? So in 2016, cybercrime apparently surpassed the drug trade in terms of how much it makes, right? That was 450 billion a year, according to this source, which is 14,000 US dollars a second. I usually have to change this into local currency, but great, I'm in the US, I don't have to do that. But it's equivalent to 50 of these humongous aircraft carriers. I don't think the US has 50 of these, right? And then we fast forward to 2022. We're now talking 6 trillion US dollars a year. That's 200,000 US dollars a second. That's equivalent to 620 of these humongous aircraft carriers. Okay, so if I've looked at some of the other data last night, even if it's 3 trillion, it's still a lot, right? That's the lower end of what they estimate. But if it is 6 trillion, we are talking this would be the 3rd largest country in terms of GDP if we put all the money made by cybercrime together. And personally, I don't think this guy would have bothered with drugs. Drug dealers, they get caught, they get shot, they get put in prison, right? If he was around nowadays, he'd probably just have loads of hackers in a basement making all the money, probably not getting caught. But if I'm using those numbers, since I started speaking at the start of this presentation, cybercrime has made 420 million US dollars. So that's a lot of money, right? Question, is that 420 million in US? Or is it called something different? In the UK, we'd say that's 420 million. It is, okay, cool. Okay. I think we might have changed to what you guys used to say. Okay, cool, thank you. I knew there was some discrepancy somewhere in the two. But yeah, AI is only going to make security even harder, right? I mean, we go back to 2006. You had, on average, 45 days to fix a vulnerability before the bad guys would start attacking you. We have now know in about 2001, with Log4j came out, that was about a day, right? So that vulnerability was announced, and within a day, everyone got hacked. Now, open source is in everything. It's in insulin pumps, it's in aircraft, it's in self-driving cars, it's in trains, right? So it is everywhere. Now, governments are changing the way they do things. They're implementing legislation to make us more responsible for the open source and the applications we ship. But for example, if you had a car that had a common fault where the wheel would fall off, you would expect that manufacturer to recall that car, right? We do not have the same laws in software as we do with hardware manufacturing. And governments are trying to change that. For example, the US is now demanding anyone that ships software to them has an S-bomb. The EU's gone a bit too far, in my opinion. They're basically making anyone who commits to an open source project responsible for that open source project if you work at a company, right? Regardless of if that company uses the open source project, you as a committer will now be responsible for anything bad that happens to that open source project, which I think is a bit too far, in my opinion. I think that's going to stifle innovation in Europe. I think people are just going to not bother committing to open source projects because they don't want to have to deal with the repercussions, or their companies will say, look, we are not taking the blame for anything you commit in your spare time, because it's even in your spare time, right? You don't even have to be working. So in my mind, that's a bit too far, but do pay attention to the local legislation because governments are legislating around this a lot. So how have we used AI at Sonatype? So I like to talk about AI at Sonatype because we were doing this before it all got popular again, etc. So we produce, again, a report about the software supply chain, and this year, last year, we had a whole section about AI where we were talking to lots of different customers, lots of people in the industry about, are they adopting it, are they using it? And we have noticed, like, loads of people are jumping on the AI bandwagon. They're trying to automate lots of processes which they didn't want to have to deal with before. It was very manual. So how do we use AI? Well, so we have lots of different products. I'm only going to be talking, AI is really only in the firewall one, but this is kind of an architectural diagram of kind of how it works in the software development life cycle. So firewall basically stops anything going into your software development from the outside world, and you set policies and things like that, and I'll explain a bit more about it afterwards. So again, using AI to stop the bad AI and bad people taking advantage, and using AI to get stuff into our system. So firewall sits between the external repositories and your internal repositories. It doesn't have to be Nexus. It can be, for example, Artifactory, things like that. And it uses machine learning to basically scan everything. Everything that goes through firewall is scanned through AI machine learning. That will then make a decision on whether it's good or bad. But even if it's good, and we've never seen it before, it goes to our security research team. It's always double-checked by a human. AI is not the sole thing that determines if something's good or bad. But it gives us a good idea very early on, and it allows our security research team to essentially have a good starting point of where to go. I need to update this number, but this is essential. So now I think it's about 350,000. That is the amount of vulnerable components Sonatype has found since we started. So we have found that didn't even exist. Nobody knew in the industry, but we have found, I think it's 350,000 new vulnerable components just by scanning stuff with Lifecycle. So how does Lifecycle work? So firewall, sorry. So essentially what happens is it comes down. If we know it's good and we've seen it before, it will then go into your system. You can do what you want with it. If we're unsure, the AI checks it. Our security research team then double checks it. If we know it's bad, we retrain the AI to look for that kind of stuff before. And these bad people, they're very clever. I've watched how the security research team do this stuff, and they know exactly what to look for. Like, these dependencies will go off to this server, it'll download this, it'll run through this script, and it'll go off to this server. So they don't put the malware or the bad stuff right there. They hide it, and they abstract it under so many layers of fetching stuff from blah, blah, blah. But the security research team knows this. So that's kind of how Sonatype have used AI, and we can give you lots of insights into how the health of these dependencies, blah, 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 things like that. So I'm going to finish a little bit early. I want to go to the observatory before I go home. I'm going to go on the way back from LAX, but I'll give you my kind of conclusion on AI. Again, this is my opinions. So AI is not going to take most of our jobs anytime soon. That is my opinion. I think current people are way overhype AI. I think they really, really do. I've been using Watson and stuff for 10 years. And has it advanced? Yes. Has it advanced that much that I think we should all be going crazy over it? Personally, I don't think so. Don't get me wrong, it's become very accessible to everybody, but I don't think it's advanced that much that, it deserves the hype it's got. AI has got popular lately because I think of how easy it's to use. Again, my mom has discovered ChatGPT. Again, it takes her 10 minutes to write her name, and she's discovered ChatGPT, and she thinks it's the most amazing thing ever. She thinks it's going to take over the world, but she still uses it every day. But yeah, I think having the ability for anyone to access this technology is the reason it's become popular. AI can make us way more productive. I automate so many things with it. For example, I have an AI bot which sits in Zoom, and it's amazing at taking notes, really good, to the point if we go off on a tangent and start talking about cars or this, that, and the other that's not work-related, it knows that that's not related, and it doesn't write that in the notes. Like, it is very clever. To the point when I first started using it, I didn't tell anyone in my organization that I had it, and I'm providing these notes, and they're like, "Wow, you're really good at taking notes, Jamie." And then about a week in, I was like, all right, I'm going to tell you, I'm not going to lie, I'm using AI for this. And they were like, oh, what are you using? We want to use it. So there's lots of practical uses for AI. Rather than us writing it down and not paying as much attention, it just monitors everything that was talked about, gets rid of all the stuff we don't care about, like what's the weather like, how are you today, all that stuff, and just keeps the actual business things we care about. But AI can be used for evil. Like I said, I've used ChatGPT to generate malware. I hope they've trained ChatGPT to not keep generating malware, but it did when I tried it. But we can use AI for good as well. We can use AI to stop the bad people using AI. There's lots of tools out there to do it. As you probably noticed, there's an explosion of AI tools nowadays. I tend to just stick to basic things like ChatGPT, and that's, but yeah, there's lots of ways we can use AI to fight the bad AI. I usually bring a load of t-shirts, but my marketing department forgot to give me any t-shirts. We generally are gathering data on Maven Central. I know you're not Java developers, so I have a few stickers, these ones here. If you fill out this information, I know it's QR code, and I know people be like, oh, security, but it kind of goes to a Google form. Feel free to fill that out. Don't worry if you don't, but yeah, it's there anyway. If you want to find any useful links of some of the stuff I've talked about today, you can go to any of these. I'll leave that there for a second. If you want to get in touch, we're around on social media, LinkedIn, blah, 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 blah. I will share some cool stuff to check out. We've revamped Maven Central. It's quite funny because nobody knew we ran Maven Central, and then as soon as we revamped it and put a Sonatype logo there, everyone went, oh, what? Sonatype are ruining Maven Central? Like, it's cost us a lot of money. All we wanted to do is put a logo there. But you can check out the new Maven Central there. If you want to check out that log4j data I talked about, it's updated daily. You can go there. And if you want to know more about software composition analysis and different tools, etc., you can use to scan your applications and make sure your project's healthy, then please do that. So if you want to find these slides, please scan the QR code there. It'll take you to my website. Please don't judge me again. I'm a back-end developer. I don't do front-end. To the point, my wife, she spent a lot of time doing front-end stuff. She actually works for IBM Security now, but I showed her my website. She was like, what have you done here? This is awful. I was like, well, it's on GitHub. You can put a pull request in if you want. So I'm going to help her write. I'm going to help her write an article on security. She came to me recently the other day and was like, she wrote this article without a topic or a title. So I'm reading this security article. It's jumping here, there, and everywhere. I was like, what are you trying to get across here? She was like, I don't know. And I was like, right, do that first and then write the article. Otherwise, it's not going to make sense. So I'm going to help her with that, and she's going to rewrite my website and make it look a bit nicer. But yeah, you can find my slides on there. Have a look. And some of my other slides are on there, and I've got recordings on there of my talks as well. But with that, I'm going to end now. I hope you enjoyed my talk, and I hope you enjoyed the rest of the conference. Thank you all. So, do we have any questions from anyone? Awesome. You're allowing me to go early. Thank you.